You guys can see my screen, right? Yesterday we went over Python, PyCharm, Obsidian, and Databricks setup. Today we will go over why the programming exists in the first place and few important developer concepts like project, packages, and environment creation. When I meant environment means virtual environment. Okay. The whole reason why computers and programming exist in the first place is to outsource the thinking, our decision-making process to a computer. This is done to make sure that the why we do this in general is humans are smart, right? They can make logical conclusion based on the given data and based on given circumstances. We can derive a solution to every problem. But what humans lack is speed. When humans wanted to perform a same repetitive task again and again, this becomes very tedious and tiresome, and it is prone to errors. Humans are bound to make mistakes. This is where programming and computers come into the picture. Program computers by themselves are not smart. They are smart because we write a logic or code into them so that when given a specific set of data, implement, they can follow these instructions on that data and derive a result. And where programming languages and computers outshine humans is their speed. A computer can basically perform millions of tasks again and again without having to take breaks, unlike a human. This is the whole point of a programming and computers. And let's go. Python as a why? When I meant a programming languages, it can either mean any language. There are languages other than Python, right? Like Java, C, Scala, and there is even R, Golang, Flutter, and JavaScript. And there are plethora of languages in in the development landscape. Each and every one of them has their own unique traits, but at the core, every language is used to write instructions so computer can follow those instructions and make decisions, produce an output, right? Like our Python is called a high level programming language. The name high level just means that the code we write can be readable by humans. Let me show you an example. I have a text. This is See, you don't have to understand what this means. Just if on is in comma on is present. See, here you don't even need to know a line of Python code, but you can make out what this is doing, right? If John in something like this list, print John is present, right? You don't know anything about Python, but you can make out something from it. Like I am testing that whether John is in here. If John is in here, I am trying to print something like this. This is what high level means. High level means that the instructions we write are human readable. Then you may ask, when we are writing instructions in human readable as text, right? How can a computer understand this text and execute our instructions one after another? This task is basically done by our Python. Yesterday we installed multiple versions of Python, right? Python 3.12 and Python 14. These Python 3.12 and Python 14, what they do is they take our Python code, convert the high level code, that means that text, the high level text we wrote, and converts them into machine understandable code. And then the operating system is the actual Operating system is the one that actually executes these instructions. The role of Python is just convert our high-level code into a machine understandable code, and the operating system executes this code and returns the results back to Python. Returns the results back to our editor, and our editor prints the results. Clear, right? Now we understood what a why we should use a programming language, the whole reason why we ended up with the programming language, and how the high level languages behave, the code is written, and how the code is translated. Python translates the code, and operating system executes the instruction. Here, even as a human being, when we try to make decisions, like let's say we wanted to go for shopping, right? When we want to go for a shopping, how our decision making process will be something like this. Do I have enough amount in my bank account? Okay, fine. Do I have any more expenses? Based on this given data, the amount of balance in our account and the amount of expenses, and depending on what we want to buy, do we want to buy a car, or do we want to buy a bike, or do we want to buy clothes and stuff, we make our decisions, right? Here, the amount of our decisions are based on the money. Money is nothing but a number, a numeric data. Our decisions are based on the numeric data, and our decisions are based on the things we want to buy. The things we want to buy, like a shirt, car, or a bike. Here, the shirt, car, and bike can be represented in our code as strings, text. So, our decision making process is determined by data, like numbers or images. You can skip text files and fine. Just understand that when a human being tries to make a decision, our entire decision making process is dependent on some type of data, like numbers or some text strings. Like if you want to buy a shirt, we what we do is we basically read the tag. On the tag, we read text, right? Who made this shirt and how much does this shirt cost? And the everything that is written on the tag is represented as text is our data, and our decision making processes depends on the data. Sometimes you might be familiar with text files, right? Let's say we write some logins into our text files, and even Excel files. We can write our expenses into uh, our Excel files. These are all nothing but files to store data. Python, I think I have covered this earlier. Python is nothing but a text written in a Python file. Can an operating system run Python code directly? No, because the Python should convert the Python code into machine readable code, and only then the operating system can execute the code. The role of Python runtime. Python runtime is nothing but our Python that we installed. Full stack overview, local execution, conceptual. So no, you don't need this. Now we learn two things. There is something called Python, and there is Python and Python code, and there is something called data. And our decision making process depends on data. Just like that, we know it, even the Python code, the instructions we write also depends on the data. Now we will understand what a project is, package, and an environment, virtual environment is. Let me close project. See, when you open the PyCharm or any IDE for the first time, you will see something like this. Here, you can see names, right? These are nothing but folders on my system that I opened using PyCharm. PyCharm will automatically remember that, hey, Tarun, you have already opened this folder, so I am showing it to you again. Do you want to open this folder again, or do you want to open a new folder again? See, here you can either open an existing folder as a project, or you can open already folders that you have opened before. Or here, this button even you can create a new project directly. Project is nothing but a folder that stores our code. When you try to create a new one, you will see something like this. This doesn't make any sense. Here, I think this will make sense. The location, at least the location you can understand. This is asking me to where do you want to put your project or the location. Let me PyCharm projects. No. Okay, let me do this. PyCharm projects, students project. Here I am just asking the PyCharm to create a new folder with this name in here. And here, this is asking me to select an interpreter type and Python version, right? I think you can understand this. Which Python should I use to run this code? As for interpreter, you can leave it. Mm, project packages in environment project. Yeah, project is nothing but a folder that where you put your Python files in. Here we have created a sample project, right? The project is named students project, and this has just a main file. Let me put some students is also something in the students. See, let's say our student projects has some few files, few Python files. Now, yesterday I told you that you can run a file like this. You can right click on the file and you can just click on the run, and this will run the code. But what you need to understand is, let's say we have a college project. Here, this is a student's project, right? We have few files, something like this. Yes. ₹1,00,000 घालतो तिकडे उतरतो मला खाली Placement and instead, where is the structure? For example, sending instruct. Yeah. Example, violation. Okay. Let's say we have a student's project and you have worked on the project for a few weeks and created some files, some 5 to 10 files in the project. And then they asked you to work on a college project, and you found out that some of the files that you wrote in your student projects can be directly copied from there and pasted into your college project because the functionality is identical. In such cases, will you write a new file? No, right? You will just copy that file and place it in a college folder. In the same way, what if there is a piece of Python code that I have wrote, but I thought that most millions of developers can reuse the same code. In such case, what we call that file is a package. What we do is, see, I have this file. I have used this file to do something to implement some functionality. So I am sharing it for the web. So other developers can install the file directly and use the same code again without they having to develop the same functionality again by themselves. And such packaged code, the code that is shared to the world by a developer, is called a package. For example, let's say we want to send an email. It's not like you can directly, I mean, you can do it. Like you can write a new Python file and use some Python functions to write down a function that can send an email. But what we generally do is someone must have already gone through this problem. Someone must have already solved the problem of sending an email to someone else and created a package and published it online. All we have to do is search for the package, install it, and then use the package again without us having to develop the email functionality again. I think you should get what a package means, right? Is there anyone who doesn't understand the package? No. Okay, good. Then let's say we are using a email sending package in one of our students' project. We are using this package to send emails to students who didn't pay any fee, right? Yes, did And the developer of the email package, what he found out was he found out that the package he published to the world has an error in it, or he wanted to publish a new function that can send emails to multiple people at once, or send an email to a new, like say a Hotmail or Yahoo Mail, which didn't exist in the previous version. What the developer can do is he will give a number like the first package I developed will be called number one, so version one. I will push the latest change. I will develop the changes and call the latest package number version 2, something like this. The previous package is called version 2.1.0 and the newer version is called 2.2.0. The numbering can change a bit. Like it can be 3.2.0. We should get the picture. Whenever a developer pushes a new update or a bug fix to an existing package, the number is generally increased. Now, you may ask, why should the developer or we using the package should remember this number? Why can't I just put like this? I will just use the pandas. I won't remember the version in my code. You can ask something like, but this is dangerous because whenever a developer pushes an update to a package, what he may do is he may remove already existing functionality or add a new functionality. So, in order for us to if we accidentally install a newer version, it might break our code. Our code might have been using a functionality that the newer package must have removed, right? Let's say I have worked on pandas 2.1.0 and it exposed a few functions. I am using them in my code, but some other developer accidentally what he did was he ignored my version and installed 2.2.0. What may happen is our code is correct, but the package functions that doesn't exist. So when someone tries to run our code, it will break. Just remember this, that a package is a code that is available on the web that we can install it, and each package can have multiple versions, and we should strictly remember which version we are using in our code. And whenever we are updating from one version to another version, increasing our version, there is something called a release docs. This will be available with the developer will, along with the update, he will give us a document. In this document, he will list down the changes he made. We can just go over this slightly and check whether the any functionality that we are using has been removed or anything new has been added, and make the necessary changes in our code base in order to use the newer version. Good. Now the environments. Someone earlier asked me, I failed to set up an virtual environment, right? But I have already told you that PyCharm is an editor. It helps us to write the code. Python files store the code, and the Python is the act one that runs the code. I mean, translates the code and sends it to OS. OS runs the code. Then why should we need an environment or virtual environment? Because what happens is this image visible? Yeah. Let's say we have two projects or two folders in our on our system, a school management project and a college management project. And a school management project contains a students.py file, a schools.py file. some Python notebooks and requirements.txt. Requirements.txt is nothing but where we write our packages, like the packages that this project depends on. This kind of looks like this. Let me show you. Let's see which one should I pick up. See here, we just write down the package name and we write down the version. Here I have written Streamlit is equal to 1.54.0, right? This means that this Apache Spark project depends on downloads or needs this Streamlit package, and that too exactly this version to work. Requirements.txt file is nothing but where we write the packages that our project depends on. We generally, the name should be exactly with this requirements.txt. Now let me close. Let's return back to our projects. We have two different projects, a students management project and a college management project. Let's say that our school management project and college management project both are running on Python 3.12. I mean, both projects have been configured to run on Python 3.12. That means whenever I execute code and school management projects, it will run on Python 3.12. And even when I execute code on college management, it will also execute on Python 3.12. Like I said, right, we can have multiple versions of Python installed and on our system, and this won't cause any problem. We can individually pick which project runs on which environment, which runtime. See, you might notice that this by itself is not a problem, but the problem arises when two different projects depending on the same runtime by itself is not a problem. But the problem arises when our school management projects depends on, let's say, depends on a package name pandas 2, and our college management project depends on pandas version 3. Now, when we try to install a package, the package is installed directly in our Python runtime that we are using along with the project. Now, say in school management project, I tried to install pandas 2 and it got installed in Python 3.12. Now, when I open college management project and tried to install pandas 3, what it did was it overrode the pandas 2 in my Python 3.12 and it installed Python pandas 3. Now, if I visit back my school management project and try to execute the code, what it will do is it will break our code, because school management was meant to depend on pandas 2, but pandas 3 got installed. You might see the problem when multiple projects running on the same runtime need to have different package versions. Running one project will break the other project. This is a problem, right? Because a developer will have multiples of projects on his system, and we can't have him whenever he opens one project, we can't have him fix the rest of the 9 projects every time. This is where the environments or virtual environments come into picture. An environment is nothing but a folder. The folder name will be .vnv or just vnv. What environment does is it will copy the Python. Let's say we can create an environment on any Python version. Let's say we can create an environment on Python 3.12, or we can even create on Python 3.14 and such. This folder will copy the Python and store it in, and also it will store any packages that user.
అది మళ్ళీ నువ్వు వాడేయటం నువ్వు కొట్టడం మళ్ళీ ఊరుకోవడం ఆ డిస్టర్బెన్స్ కాకుండా ఆడండి.
Yeah. Now, instead of making our project depend on the runtime, run on our runtime directly, what we do is we put an environment in between. What happens then is our packages are installed in the environment so that even when we open another project and try to run our code, it will not affect the it will not be affected by packages in the other projects. Is the concept of environment clear, or do you want me to go in detail again? So I am assuming that everyone understood environments, right?
Here environment means in PyCharm and VS Code like that.
Yeah, okay. See, environment by itself is not dependent on the IDE. This concept is generic. Just like how we installed Python, and Python has nothing to do with PyCharm or VS Code, right? What happens is the general environments are created something like this. Python dash 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 Python 3 dash dash dash. Yeah, this is showing me that I have Python 3.12 installed on my system, right? PyEnv, give me a minute. Let me search for it. Setting up no, command to create environment in on Linux. Okay. Python. How to create a Python dash C when I am. Yeah. See, Python dash 3 when when here I am asking Python to create an environment named new VNV. This can be any other name, but by default, what we do is we just let me put see. I am asking Python. See, Python. Can you create an environment called my VNV? Can't open when either no such file or directory exists. Dot slash when my VNV. Here, let's see the downloads. MKDir. Python 3 when my env. Can't open sudo Python 3. Okay. What I basically did was I created I opened my downloads folder. There are too many, right? Let me delete them. Yeah, I will do it again. Okay, see, I am asking, I am instructing my computer to create an folder called VENV in downloads. Folder name is VENV. Now I am asking Python to convert this environment, to convert this folder into an Python virtual environment. And my env is the name given to that environment, so I can find it easily later. See? No. See, this is the reason why we won't create environments directly. In case of VS Code and PyCharm, instead of running the commands, this will provide an interface to do it directly. Let's see. Here, if I wanted to create an environment, we have something called interpreter settings, right? If we open this, we can either choose an existing interpreter, or here 312 student project, it already created for me, or I can even create a new one. Here I am clicking on add interpreter, and even here generate a new. And here this is asking me which Python should I use to create a virtual environment. Here I have 312 and 311 and 310. I think you should see 314 and 312 because you installed 12 and 14. Here let me say I will select 12. And now this is asking me to locate location. Where do you want to put the virtual environment? Here in my case, this is showing an error because in this location, there is already an interpreter. On the left side bar, if you can see, I already have an environment in here, right? So this is showing me an error. Let me see. Yeah, here I gave a different location. And I'm asking it to create it for me. See, it created an environment in under some test subfolder in our project. Actually, the name of the environment can be just venv or .venv, but you can place the environment anywhere you want. You can even place the environment outside the project folder or somewhere else. Here, if you can see, I placed two environment, right? This is the one environment, and I created a folder in it, and I placed another environment in here. But what matters is you should create an environment. Then after creating it, you should tag it to the project. Like here, let me. Sound. Do we have a test plan? Let me ask something. Is this clear? The environment is not related to IDE. Clear, right? Anyone doesn't understand this? Okay, I'm assuming no. The environments themselves can be created directly using our terminal, but we generally try to create them using our PyCharm or VS Code. In PyCharm, if you want to create an environment, all you have to do is just go to interpreter settings, and in here, if you want to, if there is you already created an environment somewhere, then you just want to select it. You will just click it, and it will show in here. If this doesn't show in here, you can press show all, and this should show here. You need to just select it and click OK. What PyCharm does it will understand that I have to use this environment for school projects. So for students project. So whenever I open a students project, it will automatically attach this environment to our project. And whenever we run our code, it will run the code on that environment. If you wanted to create a new one, all you have to do is click on add interpreter and add local interpreter. And then you have to select on which Python version you want to create the environment and where you want to place the environment. My suggestion is never touch this. This will by default point to .venv folder in the project you open. In my case, this is showing an error because I already have an environment here. all you have to do is select which Python you want to do, or which Python you want to create the environment in, and just click OK. This will automatically create the environment for you and associate that environment with the project. So even when you close the project and open it again, this will remember. Let's see here. This remember that if you see the name of the environment is student project 2, right? Even when I close my PyCharm and open it again, let me open this. I am going to this same student's project. This will remember. If you change this from the next time, yeah. Now I changed my environment to this one or the top one. Now from whenever I open this project again, this will remember this and open this again. Good. Now you should understand why the packages exist in the first place and how to mitigate package conflicts between multiple projects depending on the same Python runtime. We invented or developers invented environments. And environments have nothing to do with the PyCharm or VS Code. They can be created directly from the terminal or using Python. But we generally prefer to create them using PyCharm because it is easier to manage. Now, the environment need not be contained inside the project. The environment folder can be anywhere. However, we need to tell the Python that in order to work, for this project to work, please use this interpreter or this environment. And the PyCharm will remember, and whenever you open the project again, it will automatically run your code on that environment. Clear? Is there anyone who doesn't understand packages or Python project and Python environments? Please raise your doubts. Because from tomorrow, I will be assuming that you know everything and I will just be sharing the code and you are expected to put the code in your folders and open the PyCharm and run them yourself. Okay. I am assuming everyone understood the interpreters and packages. Good. Yeah. One more thing I didn't teach you is I told that you can install package, right? How do I actually install it? There are few ways to install it. The first thing is whenever you want to install a package, what I suggest is first write down a requirements.txt file. Take a look at the name, and in the name, in the file, you have to write the exact package version that you would like to use. This is because sometimes our projects may contain hundreds and thousands of packages, and just remembering them is not sufficient. So we are expected to maintain a document, maintain requirements.txt very strictly. Because what happens is if you didn't write the dependencies in your requirements.txt, and let's say you just shared the code to the some other your colleague working on the same project. Now what happens is he will open the project, but when he tries to run the code, what PyCharm will tell me is you don't have the packages installed. It will raise an error. Then if he tried to install a package on by himself, just knowing the name, if he tried to install it, what happens is he might install some other version than the version you have developed your code on, and this might break his code. I mean, he is incapable of running your code, even though you have shipped the exact code. This is the reason why we recommend, why it is strictly required that you should write your packages names and the exact versions in your requirements.txt. And once you have written them there, if you want to install something, take a close look at this. On the left side bar, you can see something, this icon. When you hover over it, you will see the Python packages name, right? Here you can just search for the name of the package you want to run, you want to install. Here I am searching for pandas. See, when it showed up some results, I am selecting just the pandas. And you might ask, how do I know which package to install and which version to install? As you work on the Python more and more, you will automatically understand which Python to use, which package and version to use. See, if you see, I have written here that I will be downloading 2.20, right? But in here, when I opened it, it is showing me that there are several other versions too. See, there are from 1, 2, and 3. We should generally pick a version that is 2 to 3 times older. See, even though there is 3.0.1, we don't recommend using the latest version. Let's say I want to use 2.233. I am asking it to install it. If you see, it will install. It will take some time. I am also updating in here 2.3.3. This is one way to install a package, and then another way to install is hide this, hide this. You will see a terminal icon in here. When you click on it, this will open something like this. And this is the exact command: pip install, the name of the package that you want to install, and the version that you want to install, 2.3.3. Here I am trying to, I already installed 2.3.3, but trying to install it again. This doesn't cause any issues. See, this is telling me that the requirement is already satisfied, so I am not going to install it again. Once installed, you can just close this. And there is another command too. Oh, let me write down the commands. Pip install -r requirement. What this does is it will install all the packages that are listed in our requirements file. pyro streamlit numpy. See, I am just writing down random package names, and I am executing this function, this command. See, all of them will get installed using a single command. You need not remember this command. You will learn them automatically in the later stages. Just remember, this will look something like this: pip install name of the package, name package is equal to version, which version you want to install. If you want to install all the requirements in your file, this will look something like this: pip install -r requirements.txt. If you you can even forget this. You can just look it up on the web if you forget it. What data engineers mostly use this. We just use this package explorer and then search for the package we want to install and then install it. Good. Now I have covered over how to create a folder, how to open the folder using PyCharm, how to attach an interpreter or create a new interpreter and attach it, or attach an existing interpreter. When I meant interpreter, it is more or less equal to environment. How to create a new environment, how to attach an existing environment to a project, how to write requirements to a TXT file, and how to install packages in our environment. Clear that? Yeah. With that, all the fundamentals are complete. Even if you have some doubts, go through these notes, and they are very clearly written. I am just briefly giving an idea of what overview, but you can go through this, and they explain everything step by step. They even explain how to create environments and manage them in VS Code. You can even use VS Code to take this course, but I strongly encourage you to only do it using PyCharm. Good. Naming convention. You can skip this naming conventions part. If you are interested, just go over it. Python ID, setup guide, yeah, complete Python ID project environment. Yes. Good. With that, we completed the fundamentals. Now we will start Python basics. Please. Yes. Yeah. I will after the class. This is all the notes you will all the Python related content that we will be going over in the rest, I think 10 days. In the next 10 classes, we will be going over these topics. First, we will go over data types, then go over strings, lists, tuples, dictionaries, and set. If this doesn't make any sense, you can ignore it. Then we will learn how to write expressions, conditions, looping, and finally functions. I will be skipping classes because as data engineers, we are not expected to know the class behavior, but I will be providing you the notes for the classes. If you are interested, you can go over this. That's it. Today, let's go over introduction. Yeah. If you can see, these are Python notebooks. As I told yesterday, Python notebooks, we can write code and text one after another. And the reason why data engineers use this mainly is that this is very helpful for documentation. Like if there is a step, let me go over what data engineers do actually. Data engineers, their data will be stored in a database or some files, or Excel files or CSV files. What we are expected to do is read the data and apply some transformations on it, like clean it, then save it. If we just write the code, this will be very hard to digest, right? Reading the code and understanding what this does is very hard. So what we do is we break up our code into multiple cells and we will write what each cell does individually. See, let's say we have a code in one cell. We will explain what this cell does in the next cell using the text. In our case, we will be using the Jupyter notebooks to go over the execute code and go over what this code means. Good. You might have had this very frequently. Python is an object-oriented programming language, and this will not make any sense until you visit the classes. Just remember that everything or every data, every form of data or every construct in Python is an object. And let's say, how should I put this? Let's say there is a 10th class, any 10th class from any school. In this 10th class, every student will share some features, right? Every student will have a name. The name itself can be different. Each person can have a different name, but every student will have a name. And every student in the class will have a roll number. And every student will have a gender, right? The values they might take may be different, but the attributes or the features that every student in a class shares are called attributes or features. Similarly, if in a Python object, every object has few attributes. The attributes define just like how the name, age, and gender tell us about a student. The attributes tell us about the object. Similarly, if there is a student can perform certain actions, right? Student can attend a class, student can write an exam, student can review his answer sheet, student can come to the school, student can leave the school. Here, all the actions performed by the students are shared across every student, right? Let's say there is a student called Ram and there is a student called Mohan. Here, the Ram will have the same set of actions and Mohan also will have the same set of actions. And the common actions for an object are called methods or functions. Just remember that everything in the Python is an object, and an object can have attributes, like something that explaining the feature of the objects are called attributes or fields, and the actions or functions that can be performed on the object are called methods. Object has attributes and methods. Types of objects. Good. Let's skip this. Let's go over use cases of Python. If you are new to a programming language, and especially for Python, it might be quite confusing. like we write code and we don't know what that code does, right? Now, in this section, what we will be going through is what can Python achieve? Like if I write a few lines of code, what can this Python code do? Python can be used to develop web development. When I meant web development, let me show you an example. Here, www.bitbucket.com. See, when I visited this URL, you can see a website open, right? Python can be used to create a website. That means whenever we open an URL, it can take us to a web page that looks like this. The reason why I showed especially this page is everything in here is written using Python. Like how what how this name should look, how this icon should be placed, how this code and CACD should look, the font, the weight, how this button behaves when I click it, how the icon is placed in here. Bitbucket in particularly is written exclusively using Python. So Python can be used to create web apps. Web apps are nothing but interfaces. When we click an URL, it will open a website. You might be familiar with YouTube, and YouTube is also a web app. Even the WhatsApp web is also a web app. And Python can be used to develop web apps. That is the one use case of Python. And the next one is microservices and API. This might be hard to digest. Let's say you wanted to add two numbers, right? What you will do is you can either do it mentally or you can open a calculator and write 1 plus 2 is equal to 3. You can ask a calculator to do it, and it will return the results. What if you want to do the same on the web? I mean, you want to perform a task, but this task will run on some other system. That is what we call a microservice. Microservice is nothing but we give the data on the web. The data will be transferred to that computer. The data will be processed on that computer and the results will be returned back to us. And how this is done is, let me show you an example. https://clarity.com/. No. SQL. The wrong one. Yes, column double slash SQL dot API. See, this is just some random URL. When I hit this URL, when I type this URL into my browser, what it returned is app environment is equal to production. See, this URL and this when I ran this URL, what this done is it sent a request to the another system across the world, and that system sent me the name of the app is production. Similarly, we can even send something like name is equal to something, age is equal to something. Please calculate ticket rate. This is not implemented, but the Microsoft APIs behave something identically. What they do is when we will pass them some data, the data will be transferred to the service will run, and it will return back the results. Everything is done on the web. In case of your calculator, you enter the data into the calculator and the calculator showed the result, right? In case of APS, you will give the data over the web and it will return the data, processed data over the web. And the process of writing such functions is called microservices or API development. Database interactions. Yeah. This is the core part of the data engineer. But you won't be able to understand it. Just skip it. Let's do this later. Machine learning, other domains. Yeah, let's skip this. Just know that Python can be used to create web applications. Python can be used to create APIs. APIs are nothing but remote functions. You will give some data, they will work on them, and they will return back the results. Database, how should I tell? Let's say you have a Google Drive, right? Every one of you use a Google Drive, right? Have you ever wondered that when you upload a file on your mobile, you can access it even using another mobile if you just log into the same Google account? Have you ever wondered how can this happen? The file is on the one mobile, but you can access this on the other mobile. What basically happens is when you upload something or any file to a Google Drive, what this does it will copy the file, store it somewhere on the web. It will store it somewhere on the web. Just ignore where it is stored. Just remember it will store on the web. And whenever you open the drive on another app using the same account, it will pull the data stored on the web and show it to you. And the place where this data is stored is in general is called a database. The entire work of a data engineer is to fetch the data from a database. The data will be generally raw. Let's say there is an application that is accepting user login, user data, let's say ticket booking app. What ticket booking app generally takes the username of it will take the source destination, it will take the target destination, and it will store it, right? The place where we store this data is called a database. And the data in our job as a data engineer is the stored data by itself doesn't translate to business needs. Like if I wanted to know how many users booked a ticket from Hyderabad to Mumbai today, this cannot be achieved, right? Developers just store the data in the database, and data engineers are the one who are responsible for pulling the data from the database, working on it, and generate a report and give it to our sales team. And based on this information, our sales team can make decisions for us. Like they can see whether the bookings have been reduced. Should we reduce the ticket price, or bookings are overflowing? Should we add more servers into our system to handle the peak traffic and such? Yeah, if you don't understand this, you can ignore this. We will go deeply into what databases are and data storage techniques in the later parts of this course. Good. Yeah. Python introduction. And from tomorrow, we will start Python coding classes. And since not tomorrow, from Monday, since tomorrow is a Sunday, I recommend you to watch. Let me go over. Walk. Learning Jupyter Notebooks. Jupyter Notebook tutorial and Python Jupyter models. Beginner guide. What I will be sharing this link over Zoom. What I want you to guys to do is just go over this. Just try to understand what Jupyter is. Control V. This class, and let me give you another one. learning Markdown. Literally learn Markdown in 60 seconds. Shots. The only Markdown task force you ever need. So I want you to